Well, we can get started today then if we don't have any volunteers. So, Elijah, thank you for coming today and leading this workshop. Elijah is the founder of Base Design Studio here in Pittsburgh, PA. Base specializes in offering industrial design, UI, UX, graphic design, and branding for startups to multinational corporations. Elijah and his wife Leah are also founders of Spruce Pup, which makes innovative, well-designed dog products. Elijah has worked at many firms through his career and is named on over 20 patents. He's also won 3 Red Dot Design Awards along with many others. So I will let you get started. Thank you.
Thanks, Allison. Thank you. Thanks for joining, everybody. I really appreciate it. And this is a little different than being in person there at the center, but I call this talk Designing at Super Speed because one of the things we specialize in here at Base is very agile, very quick product development, design development, whether it's UI, UX. We try to go really quickly, and we only work on what I call the puzzle pieces that a business needs to succeed. You can design for a long period of time, but you really, when you have limited time, limited budget, and you need something there, that's kind of what this is about. Let me click through here. Oop, there. So as Allison mentioned, I'm the founder of Base Design Studio. We've been with Base probably about 7 years at this point. We do all range of products, and a lot of that has grown out of, previous to that, I was the design director at For Moms, the local Pittsburgh company that was a startup and is now one of the bigger players in the juvenile space. So I was kind of employee number 8 there when they were a startup and first designer. We designed the Monroo and the strollers, and then eventually we've grown that into a giant company. When it was time to leave, I looked at it and we were like, what's even a cooler industry than like babies, or better for kind of business? And the answer was pets. So we've also started Spruce Pup. You'll see the bed there, and we make a bunch of other products. That's kind of our side business that's more of a consumer-facing product company that you should check out. So a lot of the times, especially with entrepreneur programs or thinking about the way business, engineering, design all kind of coalesce, we are under the design thinking bubble, because you can do design thinking as a business person, as a designer, as an engineer, as a logistics person. Any of that can incorporate design thinking, which really, like, when you boil it down, it's the process of taking uncertainty and a big mess and adding focus to it, right? And the way you do that is through researching the problem, prototyping solutions, and then incorporating and executing on the final design. So at the bottom there, that's kind of what that shows. Designers like ambiguity, and that's why we tend to be the ones in the room that are jumping into that process more with ideas or more with potential, or what could this be. A lot of the time that might go too far, but whenever you're thinking about any design thinking, even if it is something as simple as thinking about product logistics of how you're managing your warehouse, you should dive into that ambiguity a little bit. You should welcome that. You should start parsing ideas, put the Post-its up on the wall, and start coalescing them into things. And that's a big part of what my earlier kind of tips and tricks are going to be about here as we go through. Designers, right? Like on the project side, we're the sensitive artists, So like that blue is not blue enough, or oh, I just can't stand that. Why can't we get rid of that button on this thing? Oh, it's awful. Or do we have to have those rivets? The rivets, I can't believe, we are those kind of sensitive, asking the questions people that might get, like an engineer, a software engineer, like kind of, come on, it's the same blue, it's fine. But the important thing about that is we're also a bit of the canaries in the coal mine. So because we're sensitive to things like that, or a good designer is looking at those things and flagging those little product nuances, that's where it actually becomes the client's job to actually be thinking about that from either a consumer perspective or your clients or whoever your final customer is. You want to ask yourself, have you actually tested that? Do you really want to know like the truth of like the prototype's way too big, or are your costs way out of line? Does anyone even want it? Like that's part of what design thinking helps you distill down and to start digging into. We're those sensitive people that are going to say like, well, why does that work that way? And could it work another way, or would people like it better if it did that? So in that design thinking, we have the typical design process, and this is pretty. I mean, it's pretty etched in stone in some variation or another. So step one is you want to empathize. A good designer can be a 90-year-old woman trying to open a bottle. They can be a 3-year-old child playing with, the toys hanging above the toy mobile. They can be a dog. They can understand how what you want to do is dig in and get a deeper understanding of what you're trying to solve. You want to kind of gather, empathize with that group. From there, you want to define your problem. You want to clearly say what you're trying to solve. So a lot of the times an entrepreneur will say, I got a new widget. And you say, okay, but why? And you need to define that problem that you're trying to solve, because that helps you develop constraints, which I'll talk about in a bit. Once you've got that problem articulated, you want to ideate on it. You want to come up with brainstorms. You want to go broad. This is casting your net over the whole thing, throwing the spaghetti at the wall to see what sticks, all kinds of ideas, and then you start prototyping those in stage 4. So whether it's physical testing or even just talking it through, a plus minus graph to pros and cons, any of that is prototyping it. You want to test that with your consumer base or with your investors or with your business partners, whatever that is, you test it and then you repeat that process. So it is very, very cyclical. This is that front end question stage. You want to be asking like, what if we could make a device that could tell you where you were at and also do this? You want to open that up in this first stage. You ask questions, like I said, like what if? From there, you want to test those ideas quickly. When you don't say no to any of the what if ideas, those are kind of big crazy. What if it had lasers? What if it could fly? What if it could fold, this big? You welcome all of those, but then you immediately start testing them and shaving off the pieces. This is Oxo's very famous design for the hand, an ergonomic handle, but you really want to test and iterate on those ideas. That iteration is again where you're trying to solve for something. So it's about volume and kind of going to this end of the spectrum and that end, and then kind of everywhere in between that. And then that last stage is that focus. I think a lot of the times one of the biggest pieces that trips up small companies, entrepreneurs, innovative startups is the focus. Because if it truly is a new idea or a novel approach or somehow shifting behaviors, knowing what to focus on, usually you have a pretty big bag of tricks that you're thinking about, and it could be that focus. We've got a bunch of kind of exercises here in the end I'll talk about to help engage that. So these are just some exercises that are really important, and I think as each of you either takes part in either a company you work for, or a company you're starting, or a design problem in school, or any of it, all of these are kind of like little playbooks, little cards that you can kind of go through to help parse out that information so that you don't feel. All of these exercises become intuitive to a good design thinker. Question and hypothesis. So there's all sorts of activities you can do. Storyboarding is the act of either writing down, drawing, or even acting out the use of the product. So if it's a new ATM machine, thinking about, wow, okay, first I walk up to this, then I connect it, hit the buttons, then I get the. You do connections, and connections kind of is clicked over to that. That makes me think of. That makes me think of is one of my favorites. Especially as a design director here, of we get ideas and then you want to run with those. At least in this early stage, you say one of your designers or engineers shows up and says, "Hey, I developed this really lightweight handle." You say, "Ooh, that's cool. That makes me think that what if that handle was attached to this, or what if so that makes me think of is an additive process. I compare it a little bit to like improv because you're saying yes and. In improv, you always want to say, "Oh man, there's a giant bat on the ceiling," and the other person shouldn't say, "No, it's not." They should say, "Yeah, it is, and it's turning into an elephant." Whatever that is, you want to build on that. Wishing is a really good one. You don't have to solve the problem. You can wish that it was solved. You can think of, you can say, I wish this chair could be as light as 2 pounds, and then you work towards that solution. Connections are really cool. I mean, this is the typical, like iPhone development way back when it was, what if we took an iPod and a communication device and an internet browser and smashed them all together? So a lot of the times, looking at these connections is what opens up other business opportunities or markets you might not think about. A lot of the times, what's obviously a lamp, if you just think about what could you add that lamp to, all of a sudden that banana adds another depth to it, right? So all of a sudden it might pivot your business to a more profitable sector or some better conversion rate. This is that representative of that makes me think of, because it is this networking branching out process. Wishing, you don't have to necessarily worry about the physical constraints. You can just think, wouldn't it be easier if, and then go from there. Then it's really about the testing of all of those. Once you've got a few hypotheses and some questions, okay, let's focus on making a super lightweight, durable, easy to use chair. It doesn't matter what this is, but you want to test that quickly. So you have your hypothesis, you start iterating on it, right? You try it with wheels on the bottom, you try it without wheels on the bottom, you try it extra wide, you try it shorter, you try thinner pipes, larger pipes. There's an iterative process that you want to be refining, and at that second phase, you really want to be spending time here, because the more time you spend on quick, rapid iteration, the more money you save in the back end and changes towards what you want to be focused on. And then, like I just led up to, focus. You have to pick a few of the ideas. You can't pick everybody to be your teammates or every feature to be in your product. Just that doesn't work. That's how you get these camel solutions. You want to be able to focus those iterative ideas and those problems that you listed out into your direct design in the channel. How do you focus? That's something that people ask a lot of, like, okay, so I've got 10,000 ideas here and I've iterated and I've got 5 that work, but how do I focus on what do I need to work on? You need to know the constraints. This is Charles Eames. He designed this beautiful chair along with everything else in the 1950s and 60s. I'll let you guys read this, but it's all about constraints. A lot of the time, people view the constraints of the project as limiting factors or as handcuffs or, putting it in a box, keeping it locked down. And his willingness to jump in and work with those constraints that's where the real design process comes in. Knowing that you can't really ship a 800-pound product to every single user that you might want to, like, that's an important constraint. You need to like approach that and embrace it rather than running from it. So one of the first steps is you study those constraints, you list them out. So now you have your problem that you're trying to solve. You've kind of come up with a few ideas. To then vindicate those or do the checklist on them, you want to study the constraints and ask yourself, what is the most important consumer benefit? What's the most important business outcome? What's the most important whatever? And then the second part there in parentheses is something that a lot of the time entrepreneurs don't do. You want to tell them to everyone on your team. So a lot of the time, we get so excited when we get into an idea and we know that the most important feature is that this folds up into the size of a soda can. We know that and we've lived with it, and it's been 2 years of development we've been working on it. You hire a new guy and you say, hey, I need you to work on this little aspect of this. And if you don't tell them that it has to fold to the size of a soda can, they can't effectively do their job. So not only do you need to know the constraints, but you need to agree on them as a team. Everybody on the team needs to know we are working towards a soda can size fold. Secondary is it lighting up, whatever. So as you're prototyping those ideas, you want to be able to sort them and organize and filter them, right? So that refinement stage that I talked about, the plane wings that I showed you, as you're getting all these ideas and you're ideating, and this one's got a handle up here, and this one's handles here, and this one's got 2 handles, and maybe it's like this, you want to start organizing and filtering those into categories. Because as you get those prototypes or those ideas into categories, that's where you start seeing the larger trends that might be developing. So you might see that all the versions with wheels, the early test survey users really dug like kind of the wheel concept. So let's dig in there a little bit more. So that helps you really quickly decide where to commit your time and resource. Prototyping this is a great sketch by Bill Buxton from his book. There's 2 different variants, right? Designed is that branching out the tree that you see on the left there. And you have different ideas, your one initial idea. Let's make a travel bed for dogs. And then you try 2 or 3 different versions, and then there's iterations, and maybe it's this. Maybe the most important thing is that, and you try it. But when you hit that red line, all of a sudden you need to start like branching off into one. Because if those branches go further past the red line, it's time consuming, expensive, difficult, large scale, so stuff starts breaking down if you pass that red line. Whereas prototyping, that red line goes with you through the process. And as you iterate and you're prototyping and developing an idea, you spiral down and get tighter and tighter into a really distilled, clear product. When you're at the end of that little spiral there, that's the type of product that can have a 30-second elevator pitch of, my software app is all about enabling the last mile mobility, or whatever that is. But there's 2 different kind of thought processes in there. You also want to be asking, as you're prototyping or as you're doing this iterative spiral stage, what is this prototype about? You can be doing prototypes that have really high fidelity, which means painted, they're true to size, they're an actual 3D printed or physical product. They look like they will, and they're all bolted together perfect. And that's great for getting in front of users, but it's also very time consuming, super expensive to do. There's down in the bottom left there, you've got proof of concept, right? So those are only testing maybe a component of the design. And they're low fidelity. They're a piece of cardboard duct taped to the wall that you can pull up and down. Yep, that seems good. That's a proof of concept. Any of these are viable ways to make a prototype, but you need to understand what kind of prototype you want to make. A lot of the times, clients come to us and they say, we want you to help us develop the design. And what they mean is they want a looks like physical prototype that works, can plug in, has the software on it. And that's just impossible to start with, right? So a lot of the time we ask them, are you pitching this to investors? Well, then that's the upper left, right? Selling an idea, high fidelity and showing components. Or are you doing this internally to build with a manufacturer? This prototyping stage is not about how you make it. This is like a 32 move mold, just super complex and like, insane. But it's not about limiting it. It's not about saying, oh, we can't make that, or boy, that's expensive. This stage is about getting the ideas and just iterating in that spiral. With prototyping, this is the best guide I've seen. The link is in here, and I'll share this presentation, so don't worry about writing it down. Loughborough University did this amazing chart where they talk about the different ways to prototype, starting with the simplest ballpoint pen idea sketch, a memory sketch, coding, so if you're doing flow charts or diagrams, memory sketches, an information sketch shows the detail and explains, this handle lifts up this way. It goes all the way into, layout renderings. So a lot of the time, I use this as a reference when we're proposing to clients or we're telling them the stages. I'll say, okay, at this stage, we'll end up with a layout render. I say, what's a layout render? He said, that. Okay, cool. Diagrams, cross section. This is just a great guide, super inspirational. And it also helps you understand, is this a sketch model that's like blue foam and carved out? Or are we actually going for an appearance model where it's painted foam? Or is it an ugly robot that rolls around, but it works? That's how you align with your team on what you're developing next, which prototype you're working on. And this is, like I said, just the best guide that I've seen in terms of all of that information. So drawing. Everybody's scared of drawing. You don't have to draw the physical thing. You don't have to be an artist. You can start by drawing mind maps, flowcharts, wireframes. You can write a story that still is putting something to paper to just the physical act of putting something to paper. It helps your mind think about it differently. It helps you map complex relationships or constraints versus form compared to the manufacturing constraints. So start drawing, start mapping stuff out. It doesn't have to be a perfect model. When you get into physical, and this is not physical like the thing you can hold, but it's also software. It's running through UI. It's the actual, drawing is the behind the stage process. What I mean when I say physical prototypes is something that somebody can try, you can use, you can, dig into. You can build it. So I call it craft time. Craft time is where you're cutting cardboard, duct tape, hot glue, gluing it together, or digitally, just grabbing some icon, putting it there, having it click, making the thing go here. Like it's really rough and loose. You're kind of just using craft supplies. You can go off the shelf, right? So both physical and digitally, you don't need to invent the screw to build a prototype. Go to the store, buy the screw, and put it in the prototype. Use it, right? So as you're developing software, the same thing. There are components. Maybe you can grab this and that and plug it together to see if it works. But use off the shelf. Stuff exists already, and you can probably get something pretty close. Even better, buy things that are similar and take them apart, right? If you're designing a new drill, you should probably buy a couple of drills and take them apart to see how they're put together, use components, cannibalize, like improve on that. That's one of the first things you do in a prototyping process. As I said, you can use cardboard, tape, staples. You can use Sculpey, Play-Doh. You can be a kid again, right? If you're doing an actual form, aside from developing the electronics and the screen and the components, grab some clay and push it into the shape. Even having a physical thing in front of you that you can assign value and uses to helps your mind further that process, right? Just immediately seeing scale compared to a human. Whoa, that's going to be too big, or wow, that's really nice and lightweight. They're still doing it in cars for a reason, right? Like we're still designing with all of the digital tools. They still carve a car because there's something very humanistic about the visceral experience of touching and feeling and seeing it in real life. You can do foam. So this is classic ID 101, carving blue foam or pink foam. Now these are really great looking models, but you can carve foam to get something in your hands quickly. Soft goods prototyping. Um, this is a bit of a little tangent, but one of the things people don't do enough of is soft goods. You don't realize it, but 80% of our built world is probably soft goods, whether it's the upholstery on the chair you're sitting on, the clothes we're all wearing, the backpack you go to, bring to class, the interior of your car. Soft goods are pretty magical and unique from a molded plastic piece or a bent metal this or any of that, because as you prototype with soft goods, you can get into the real thing very quickly. It exists that much quicker, right? So when you're prototyping in soft goods, whether it's paper or fabric, all of a sudden you can be using the real fabric. You don't have to be 3D printing and saying it might work like this or it might look like that. You can actually work with real materials, which is really, really powerful. The next level prototypes. So this is where all of these stages, I would completely think that a good entrepreneur or a good startup company would start building these stage things. When you get into the next level prototypes, this is where people like us at Base Design start helping. We're engineering firms or software development firms building CAD models, right? This is a very specialized skill, and it's usually something that people jump into pretty quickly because it's easy to jump in. But you are talking about big expanses of time, specialized expertise, and it might not be creating the value compared to the time you're spending on it that a Sculpey Play-Doh model might. So that's what I talk about, like filtering the types of prototypes that you're working on. Computer renderings, right? Like in today's day and age, you can make stuff that's so real that it's better than in real life, and you can agree on materials and textures and logo placements, how it works. You can see it right there before. But again, a big output of time, energy, specialized expertise. We live in an era now where you can hit print and boom, it's there. So you can get amazing resolution out of things, and you can print out tons of prototypes, but we still do that very late in the process, because if you do it too early, you're iterating too much. You blame it on the printer. You do one little change and you say, I'm going to send this to the printer tonight so I can see it. And by the time you've come back that next morning to look at it, you've already come up with two new ideas or something different when you're that early in the stage. When you're in the middle ground, you're developing ideas and it's good to test, but to really spend the time, energy, and money 3D printing, there are so many other ways you can kind of parse that prototyping out before you're doing any print. But then it's tremendously valuable when you're ready for it. This is kind of like what I alluded to earlier, the all out. We want to work on a works like, looks like model. So not only did this prototype we worked with Carta on, it looked like it. It was 3D printed, painted parts, logo placed on there. It ran software. It had all the components. But talk about a tremendous outlay of time, energy, and literally the minute we handed it to investors and they looked at it, it was out of date, just in terms of, like what we've already learned from it. Or you spend all this time making a prototype and you hand it to somebody and they go, is it going to be this heavy? You go, yeah, no, that's too heavy. You just built a whole prototype to learn it's too heavy. There's probably a quicker, easier way to do that. Invisible prototypes. These are really good. A lot of the time, even with our software development, UI, UX, we encourage this acting it out process, right? So like this guy's, I don't know, digging or shooting, who knows what he's doing, but literally acting the process out, again, triggers those kind of mental nodes in your brain to come up with new ideas or to actually be in that process. One of the best things as a designer is to hand somebody at the table, that piece and say, okay, change the batteries and see what they do. They turn it over, they start fooling on stuff to act it out. This is a really cool one. I'm sure all of anybody with software development, software programming expertise knows this. We call it 7-14-28. You start with how to make a peanut butter sandwich in 7 steps. It's got to be 7. So you fill those in. Then you take that same process and you outline it in 14 steps. And then you double it again and you outline it in 28 steps, right? So as you delve deeper into it, you start understanding little connections that might not be, one of the games we used to play with kids when they'd come visit for mom was make a peanut butter sandwich and they'd say, get bread. And the engineer there would grab just a bag of bread and slam it down on the table. And they're like, no, open the bag. So that's where you start seeing little opportunities and little insights into what makes something a better product or an easier to use product. Those types of discoveries that customers just like lose it over. One of the other things about prototypes is scale. So I show a lot of physical stuff here, but it goes the same for digital. Prototypes don't always have to be one-to-one. They can be little. They can be, a model, right? You don't build a building without kind of seeing it in scale. At the same time, you can zoom it up, you can scale things up, but working one-to-one, I always make the comparison, all humans are about the same size, right? We don't have any 20 foot tall people. We don't have, any 10,000 pound people. We're all in at least a definable bubble, right? So working one-to-one helps you to understand, I'm designing for a human being. This desk should be about this height, or that's a big example, but you can, when you work one-to-one, you instantly are taking away any of the filtering that might happen in your prototype that might muddy the water. So a lot of times if we're designing, if you're designing, say, an ATM or a restaurant counter or anything where humans are actually interacting with, tape it off, literally go up to a blank wall, measure up, say, oh, tables are that tall, the cabinets are that tall. Wow, that's too tall. That's kind of a pain to walk over to here and then walk over to there, right? So live in that, play with it. They do it with cars, so they line it out so that they can talk about the crease lines and the views. Human scale is also the thing that as you're starting to develop stuff, start having a person hold it, start drawing it with somebody's hands in there, start stapling it onto them, like make them wear it, make them lift it up. Just putting it in a human context of scale all of a sudden gives you all of those constraints that you don't have if you're working in the computer, if you're just drawing it, if you're not working in scale. And then get it in people's hands. This is kind of my thing of, who knows how to break things? Everybody. Who knows how to misuse something? All people. Everybody knows how to mess something up, all of us. So just the act of giving your prototype to somebody, handing them that handle, 5 people are going to turn it upside down. 3 people are going to use it wrong. before people are asked if it's really going to be this blue color, right? They're going to break stuff. They're going to ask questions, but that's where you start digging in and learning about what you've built. You have to have those hard conversations, right? You have to be honest. There's a lot of times when we're developing stuff for moms where we be kind of off in the pre-development vacuum building a prototype, and then customers, we would do a survey group or a customer survey, and people would start asking questions that weren't even on our radar or even applicable, just weird stuff. But listening to those and looking at them and hearing those triggers that, wow, that what we thought was so clear is not coming across at all in this UI design, where people are really confused with that big button that says settings and has the gear, and they're just not getting it. So you got to kind of look at those, have those hard conversations, and be honest about what you're hearing. From there, once you've heard the feedback from people, users, then you want to be talking to people that know how to make stuff, right? So one of the best things as a designer is when we first start those meetings with the manufacturing partner, because they give you so many more ideas and constraints. And we're really good at vacuum forming, but we really don't do much of this. Or you want to use aluminum 6149 because that's got better sea spray tolerances than whatever it is. Those guys know how to make stuff, whether it's software development again or physical products. Vendors and manufacturers, production people, are somebody that a good designer, good design thinking should be bouncing off of. So you've got your customers, consumers, users. You've got your vendors, your manufacturing partners. All of this to prototype your idea. There's no rules in any of this, but there are what I consider two absolutes. There's no set number of prototypes that you should do. There's no prescription for that, but it's definitely more than one. And then the second part of that is each prototype is going to teach you something, right? So the more you do, the better it's going to get. Usually it's going to make that design better. And if it's not, you're headed in the wrong direction. Those are kind of my two, no matter what you're prototyping, how you're doing it, what you're going to get out of it. This is a super quick left turn. This is really direct. A lot of people say that's great, but that's big idea stuff and concepts of how to work. This is nuts and bolts, Eli's guide to making things real and real good. So this is the type of stuff designers look at, industrial designers, UI, UX designers. Alignment, line things up. Look at the number of body panels on this car. Look at their part brakes. Look at how, on the back trunk here where the taillight comes in, there's a little curve and a kick and a kick. To be clear, this is an example of bad design, right? I'm sorry if anybody drives a Lincoln MKZ, but it's not lined up. It's just hacked together, and you can see that, and it comes through, right? There's big form moves, there's little form moves. You can do a lot just by lining things up, right? So this is a Japanese coffee maker, and it's just aligned. You can see that the handle is there. It's proportional to the mechanical body, to the kettle. They line things up. They look at where the lid of the mechanical box is compared to the lid of the pitcher, and they line it up. That's one of the number one rules in even software design, website design, anything. Line it up. Look at the alignment. Build in what we call beauty gaps. This is a physical example of beauty gaps, but in cars, pieces come together and have to fit up, right? If you try to build those with zero tolerance and perfect, you're not going to get there, right? So we try to incorporate design details like this little chamfered edge as a place to hide the LEDs. That also lets you put two parts together. So when we were developing for this client, we started with this beauty gap, right? We had LEDs on the side and buttons. And this was an early stage prototype. So those two top and bottom shelves, super close, no kind of room for margin. The problem there with expecting it to fit up is real life has tolerances, things are off, parts warp, and all of a sudden you're fighting something. If you design some of that beauty gap and tolerance in, all of a sudden the design is better and stronger and more robust and more reliable. So, we built in this beauty gap sleeve, which actually let us clean up the buttons so you visually don't even see them. The LEDs go into a little trough, and that little trough is like an actual design detail that made it physically more interesting than the previous one. And it could be misaligned, so that was good. You want to pick one thing to celebrate. So you don't want to put, bright red chrome on everything, but you do want to think about maybe the handle or the power button or the one button in the app that you want to hit. Like, you want to pick one thing and celebrate it. You want to think about combining pieces. This is a beautiful example of the trunk lid is the glass, right? So instead of insetting the glass into a metal body panel, one of the engineers, designers looked at it and said, let's just make the whole thing glass. Let's combine it. And then you get this much stronger, cohesive thing. So as you start prototyping, building those pieces, start looking at what happens if I meld this one with that one? And what can I combine? What can I simplify? Use multiple materials. This goes to my soft goods thing. A lot of the time, in today's day and age, we think about black LCD touchscreen, plastic shell, top and bottom, screw it together. It's got a plastic button or a rubber button. Use different materials. The best designs incorporate something humanistic, whether it's fabric or a leather or a high touch rubber or beautiful aluminum, right? Start adding in a palette of those, and all of a sudden your design is going to jump off the page rather than being another plastic shell. Use soft goods. This is my, they don't teach soft goods enough in school. They don't, nobody knows it exists, and it's such a gigantic part of everything, right? This is a speaker that uses that as its casing instead of a molded plastic shell. So it's recyclable, it's organic, it's more humanistic, it's more interesting, it's all those things, and it's cheaper and easier to do than plastic. Play with scale. I hope this example will make sense, but as we're developing strollers, right, that pivot point on the side is scaled off of the screw. This is the screw we can get. So then you expand that. This is the size the knob should be. You expand that. This is the size the tubes are. And that's the scale that's defining the one on the left. Playing that up, looking at what is this, a joint, you say, okay, well, let's expand that joint. Let's scale it up. Let's get big with it. All of a sudden, you have a really interesting lens to view the design through. And also you can solve problems. So this big one on the right has no pinch points. There's no little parts to pinch or cut or close together. So in summary, this whole process is right here. Everything I've just described plugs into each of these modules, and it's worth just reiterating one more time. You want to empathize. You want to develop an understanding of what you're trying, what you're thinking about, the area you're in. You want to define that problem, ideate on it, prototype and build those ideas, and then test them, and then keep cycling through. So that's the entire process there in terms of how you iterate through a typical design thinking process. With that, we can open it up to questions, whether in the chat or people can just unmute and ask anything you want more clarity on, or any other questions. Any questions at all? Yeah. Let me see. I see you. Can you unmute, Nevin? Oh,
Sorry, I was just clapping.
Just clapping. Thank you. I thought you were raising a hand. That's a bad UI, right? I see you raising a hand. You see clapping.
Thanks, Eli, for doing this. This was great.
No problem. Happy to help. Any questions? My email there is at the bottom of the screen. A lot of the time this rattles around for a second, and a week later I'll get somebody that sat in on it and says, hey, I was thinking about that. What about in this case? Or can I bounce my idea off you, or whatever it is? So feel free to reach out to that email and take it from there.
Thank you. And if